The largest animal that ever flew didn't soar over oceans hunting for fish. It stalked the land on four limbs, like a nightmarish fusion of a giraffe and a stork, hunting dinosaurs. This is the reality that modern science is uncovering, a creature far stranger and more terrifying than any myth. Welcome to Dinosaurs Explained, where every fossil tells a story, and cutting-edge science reveals the lost worlds. Today, we journey beyond the bones of the Sky Titan Quetzalcoatlus, using advanced AI and biomechanical analysis to reconstruct how this incredible beast actually lived, moved, and hunted in its lost Cretaceous world. We will dismantle the pop culture image of a simple giant flyer and reveal the truth of a terrestrial super-predator. So, if you're ready to uncover the truth behind the legend, take a moment to like this video and subscribe. Your journey into the past begins now. It all starts in 1971, in the sun-baked badlands of Texas. A geology student, Douglas Lawson, unearths a bone. But it's unlike any bone found before. Impossibly long, thin-walled, and clearly from a flying animal. Yet its sheer size seems to defy the laws of physics. The creature it belonged to would later be named Quetzalcoatlus northropi, an homage to the Aztec feathered serpent god Quetzalcoatl. The name was fitting, for this was a beast of mythic proportions. But the initial fossils were just fragments, a puzzle that would take decades, and the advent of powerful new technologies to truly piece together. Imagine standing on a prehistoric plain and seeing a giraffe in the distance. Now imagine that giraffe has a 40-foot wingspan and can take to the sky. You are now beginning to grasp the scale of Quetzalcoatlus. When standing, it was a towering presence, reaching up to 18 feet in height, its head level with the second story of a building. Its most striking feature was its incredibly long, stiff neck, which held a massive spear-like head that was itself nearly 6 feet long. But unlike the dragons of fantasy, this beak was entirely toothless, a pair of giant, sharpened chopsticks designed for a terrifying purpose. Its body, in contrast, was surprisingly compact. The real marvel was its wings. These were not feathered wings like a bird's, but vast membranes of skin, muscle, and fiber called a patagium, stretching from an enormously elongated fourth finger all the way back to its ankles. On the ground, these wings were a marvel of biological engineering. You can discard the Hollywood image of a clumsy, sprawling reptile. Instead, you see the wings neatly folded, the long wing finger pointing upwards, allowing Quetzalcoatlus to walk with surprising agility on four limbs, its two back legs and its powerful knuckle-like front limbs. This wasn't an animal that merely tolerated being on the ground. It was built for it. This was its kingdom, a domain it patrolled with a confident, giraffe-like gait, its huge head held high, scanning the horizon. Now let's peel back the skin and look at the blueprints. Using virtual CT scanners that digitize fossils in microscopic detail, we can see that the bones of Quetzalcoatlus were an engineering masterpiece. They were almost completely hollow, filled with air sacs connected to its respiratory system, a trait called pneumatization. The bone walls themselves were incredibly thin, like paper tubes, but reinforced with an internal network of struts and ridges, creating a structure of maximum strength for minimum weight. It was a living, ultralight aircraft, and its skin wasn't scaly. Fossil impressions from related pterosaurs show that these animals were covered in a dense, hair-like filament called pycnofibers. So you must picture this giant, not as a leathery reptile, but as a creature cloaked in a soft, perhaps even colorful coat. But how did something so enormous get airborne? For years, this question stumped scientists. Now, AI-driven biomechanical models have provided the answer, and it's more dramatic than anyone imagined. Quetzalcoatlus didn't run to take off. Instead, it performed a quad launch. Crouching down on all fours, it would use its immensely powerful arm and shoulder muscles to vault itself upwards into the air with explosive force, clearing nearly 10 feet in a single bound. It was a biological pole vault. In that moment of suspension, it would unfurl those magnificent wings and, with a single powerful downstroke, catch the air and ascend into the sky. Your journey takes you now to its home, 67 million years ago. Forget the sweeping oceanic cliffs you might imagine. You are standing in the Javelina Formation of Texas, an environment that was hundreds of miles inland. The air is warm and semi-arid, with distinct wet and dry seasons. There is no ocean in sight. Your world is a vast, open floodplain, crossed by seasonal rivers and dotted with groves of ancient trees. You see forests of conifers, ferns, and ginkgos, but you also see the rise of a new kind of plant life, flowering shrubs and trees, painting the landscape with unfamiliar colors. The ground beneath your feet is a mix of sandy soil and rich mud left by receding waters. This isn't the swampy, tropical jungle home of many famous dinosaurs. It's a harsher, more open world, more akin to an African savanna than a coastal paradise. The silence is broken by the distant, low-frequency rumble of a herd of Alamosaurus, colossal, long-necked sauropods that are the true giants of this land. You might spot smaller dinosaurs, like the armored Glyptodontopelta, browse on low-lying vegetation. In the undergrowth, early mammals and lizards scurry ever watchful. This is the world Quetzalcoatlus was built for. It was perfectly adapted not for a life of skimming over waves, but for striding across these immense plains. A towering monarch surveying its terrestrial domain from a unique elevated perspective unlike any other creature. So if it wasn't a marine hunter, what did it eat? To answer that, you must watch it hunt. You see it moving through a fern prairie, its deliberate, long-legged strides carrying it silently across the landscape. Its head, held high on that long, stiff neck, acts like a periscope, giving it a perfect vantage point. It's not looking for fish, its eyes are scanning the ground. This is the terrestrial stalker hypothesis, an idea that has revolutionized our understanding of this animal. Suddenly, it stops. Its keen eyesight has spotted movement. With a lightning-fast downward strike of its neck and head, it plunges its massive, pointed beak into the undergrowth. It comes up with a small, struggling dinosaur, perhaps a juvenile hadrosaur or a large lizard. There's no chewing. With a quick toss of its head, it swallows the prey whole. This is the behavior of a superstorm. Its anatomy is the key evidence. The inland location of its fossils, its long and stiff neck unsuited for the rapid side-to-side movements needed to snatch fish, and its powerful terrestrial locomotion all point to a ground-based hunting strategy. Its feet, too, were relatively small and not adapted for wading in soft mud or swimming. It was a creature that walked the land to find its meals, picking off any animal smaller than itself with terrifying efficiency. It was an apex predator, yes, but one that operated more like a modern secretary bird or marabou stork, only on a truly monstrous scale. Now, let's pull the camera back and view the entire prehistoric stage. On this vast inland plain, Quetzalcoatlus was a dominant figure in the food web. While an adult Tyrannosaurus rex would have been a clear and present danger, those encounters were likely rare. For most other animals, Quetzalcoatlus was the threat. It wasn't just a predator of small dinosaurs. It would have eaten anything it could swallow: large lizards, mammals, and even the young of giant dinosaurs like Alamosaurus. Imagine the terror of a nesting ground when one of these giants strode into view. Its sheer size would have been an incredible deterrent to most other predators. It existed in a unique ecological niche, sharing the role of apex predator by dominating from both the land and the air. When it took flight, It could cover vast distances, moving between hunting grounds with an efficiency no land-bound carnivore could match. This mobility meant it wasn't just a local terror, it was a regional force. You can dismiss the myth of it being a passive scavenger, waiting for others to make a kill. While it certainly wouldn't have passed up a free meal, its entire anatomy screams active hunter. It was a dynamic and formidable presence, a creature that shaped the lives and behaviors of every smaller animal in its ecosystem. Its shadow casting a pall of fear over the Cretaceous plains of North America. The echo of Quetzalcoatlus reverberates through time, forever changing our perception of what is possible for life on Earth. Its discovery shattered the presumed limits of animal flight, proving that vertebrates could achieve sizes previously thought to belong only to modern aircraft. It revealed a diversity and complexity in the Pterosaur family that we are still uncovering, showing us that they weren't just simple coastal gliders but a group that conquered nearly every environment on the planet. This animal's legacy extends beyond paleontology. Its incredible lightweight yet strong bone structure provides a biological blueprint that inspires aerospace engineers and materials scientists to this day. It is a testament to the power of evolution to solve complex physical challenges. And the story is far from over. As our AI models become more sophisticated, as new fossil finds add more data points, and as imaging technology allows us to see even deeper into these ancient bones, our picture of Quetzalcoatlus will only grow clearer and more astonishing. We will refine our understanding of its flight dynamics, its metabolism, and perhaps even its social behavior. From a few enigmatic bones in the Texas desert, we have resurrected a titan. Through the lens of technology, we have watched it walk, hunt, and take flight in a world that has been silent for 66 million years. The journey into the past is a constant process of discovery, where each new fossil and each new line of code illuminates the darkness just a little more. The story of Quetzalcoatlus is a powerful reminder that the history of our planet is grander, stranger, and more magnificent than we can ever imagine, filled with creatures that defy our expectations and expand our sense of wonder. The lost worlds are not lost forever. They are simply waiting for our curiosity and our technology to bring them back to life, ensuring that these incredible stories, etched in stone, are never forgotten.